variance. So now we know where the center mass of a distribution lies. By calculating the expected value, we know that this is the center point of this distribution. The other parameter we are looking for is the spread, which we're going to find by using the variance operator. So similar to how the expectation operator operates on everything inside the brackets, the variance operator operates also on everything inside the bracket. The only difference is that the variance has a different definition. And the definition of the variance operator is that we need to have the expected deviation from the mean to the power of 2. So this is just a messy expression for telling us that we want to know what is the expected square deviation around the expected value. Luckily, we can rewrite this expression. If you just open up the parentheses and rewrite it, we can rewrite this as the expectation of the random variable to the power of 2, and note that the power of 2 is inside the expectation operator, minus the expected value to the power of 2. And notice here in the second expression, the power of 2 is outside the expectation operator. So now we might observe that the expected value of x, that we have already calculated, which means that we only need to find the first part, the expected value of x to the power of 2. And the only difference with finding x to the power of 2 instead of x is that we do the exact same thing as we found the expected value. We need to sum over all possible outcomes, take the probability of each outcome, times the outcome, but the difference is that instead of taking it to the power of 1, which we did previously, we're going to take this now to the power of 2. So this is the only new thing we need to find and calculate to find the variance. So let's revisit the previous example. We have 3 states of the world that are possible. We either have a good state where we're gonna gain 69%, which is gonna happen 25% of the time. We might have a regular outcome where we're gonna gain 3%, which can happen 50% of the time. And finally, we have the final third state, which can be viewed as a recession in the economy, where we're gonna lose 43% of our portfolio, which is gonna happen 1 time in 4. So now we of course want to know what is the variance of this x variable, of this portfolio returns. So we want to find the variance of the portfolio returns, which we denote with the random variable x. We're going to use the simplified calculation form, so we want to find the expected value of x to the power of 2 minus the expected value of x. And notice the power of 2 is outside here. So that means that this is just the same thing as the mu to the power of 2, which we know was this 0.08 to the power of 2, because that's what we calculated in the last session. So the only new thing is this one. We just need to find what is the expected value of x to the power of 2. So the expected value of x to the power of 2, we use the same calculation that we did when we found the expected value, meaning that we need to sum over all states of the world from the first one to the third one. We need to find the probability to end up in each of the possible states times the outcome in each of these states of the world. The only difference is that previously we had this to the power of 1. Now we want to take this to the power of 2 instead. So the first state gonna happen 1/4 of the time, where we had a return of 69%. We just need to take it to the power of 2. We add the second outcome, where we had a 3% return. Just remember to take it to the power of 2 now. And finally, we need to add the last state, which happened 1/4 of the time. And in this state, we're gonna lose 43%. And once again, we just need to make sure that we take it to the power of 2. And if we put this into our calculator, we're gonna get that this is equal to 0.1657. So let's just put this into this variance expression that we had. So this means that it's 0.1657 minus 0.08 to the power of 2. I'm just going to erase this one so we can put in the last bit here. And if we put this into our calculator, we're going to get that the variance is equal to 0.1593. All right. So that means the average square deviation from what we expect is around 0.16. However, the variance is a bit tricky to interpret because it's the average square deviation around the expected value. What we usually want to look at is the standard deviation. So I always say that we calculate the variance, but we interpret the standard deviation. Then the standard deviation is just the average deviation from what we expected. And it's very easy to find if we have the variance, because the standard deviation is just the square root of the variance. So that means as a last step, we just need to take the square root of the variance. And if we do that, we find that the standard deviation is around 40%, which means that we expect to observe an average deviation around the expected value of 40%. So this implies that if we hold this portfolio, the average return is going to be 8%, meaning that in the long run, we should get 8% on average each single year. However, each single year, we will have deviations. And everything from a negative 32% return up to a 48% positive return is very reasonable, because the average deviation is plus minus 40% around an expected return of 8%. Now we know how to find both the expected value and the variance. So now we know how to find the two key numbers of any distribution we're working with.